Welcome to The Explainer. Today, we're digging into a theory that, well, if it's true, it could pretty much flip a century of astronomy on its head. We are talking about a totally new explanation for why planets tilt. From Earth's familiar 23.4 degrees, which is what gives us our seasons, all the way to the truly bizarre case of Uranus, which is spinning on its side at an extreme 97 degrees. Just about every planet in our solar system is tilted. And the standard explanation for this is, to put it mildly, pretty dramatic. So for decades, the mainstream view has basically been that planets were just knocked sideways. The idea is that way back in the chaotic early days of the solar system, these huge protoplanets were smashing into each other. And these random, really violent impacts are what set their final tilts. It's a theory of cosmic accidents, really. But yeah, not everyone buys the cosmic collision story. Physicist Mathis powerfully rejects it with this rather blunt quote, arguing that the answer isn't a series of random accidents at all, but actually a predictable and constant mechanical process.
Okay, so if it's not a bunch of random collisions, then what is it? Well, Mathis's alternative kicks off with a really bold claim that for centuries, celestial mechanics has been missing a huge piece of the puzzle.
He calls this missing piece the charge field. Now, what is that? It's basically a constant stream of photons that he says fills the entire solar system. And here's the really radical part. In his model, these photons exert a real physical push on everything. It's a concept that, fundamentally challenges our standard understanding of physics. Think of it like this. Gravity is a pull, right? But Mathis argues this charge field is a constant physical push. He claims that this force is the real reason for planetary perturbations, those little deviations in their orbits, and that if you understand the rules of this push, well, that's the key to solving the whole mystery of axial tilt. So how exactly could this charge field decide a planet's tilt? The theory suggests that the mechanics are actually governed by a surprisingly simple principle, the principle of balance. The entire theory really just boils down to this simple idea of balance, which we can see at its two extremes right here. So if a planet is getting pushed mostly from one direction, it'll stand up straight, no tilts. But if it's caught in a perfect cosmic tug-of-war between two opposing pushes, it gets knocked completely on its side to 90 degrees. And Mathis points to Mercury as the perfect example of this imbalance. I mean, it's so close to the sun that the sun's charge field just completely overwhelms any push from the outer planets. And the result? Mercury has almost no tilt at all, just like the theory would predict. And then for the other extreme, the theory points straight at Uranus. It's positioned right between the solar system's other two gas giants, Saturn and Neptune. Mathis argues that the charge fields from these two massive planets create a near-perfect equilibrium, a balanced push from both sides that forces Uranus almost completely onto its side.
Okay, so those examples are pretty compelling, right? But can the theory actually predict the numbers? Well, Mathis claims it can, and that the math behind it is surprisingly simple.
And here it is, the core claim that the pushing force from any celestial body, a planet, the sun, whatever, can be calculated using just three numbers: its mass, its density, and its distance. And from that, you can supposedly figure out its effect on any other planet. So when he applies this to our own planet, Mathis calculates the push from each of the outer gas giants. You've got Jupiter, Saturn, Uranus, and Neptune all contributing, and each one is pushing Earth away from a 0-degree tilt by a very specific amount. And what happens when he adds up all those calculated angles? The final result he gets is 31.23 degrees. Now, think about this for a second. Earth's actual combined tilt and orbital inclination is 30.55 degrees. His calculation is off by less than 1 degree. That's pretty close. He then goes and applies the exact same method to Jupiter. Now, in his model, these pushes are applied one after another. So first, Saturn's huge field creates most of the tilt. Then, Uranus acts on the remaining angle, tilting it just a little bit more. And finally, Neptune comes in and adds that last little push. So what's the final number that his calculation spits out for Jupiter? 3.23 degrees. Jupiter's actual observed tilt is about 3.13 degrees. I mean, again, the numbers are incredibly close. Okay, so this is where the theory moves from just an interesting explanation to something far more disruptive. Because if these calculations are correct, the implications aren't just big, They're revolutionary. See, Mathis argues his charged field model doesn't just solve axial tilt. He says it also explains nutation. That's that slight wobble in a planet's axis. He even claims it could undermine a lot of chaos theory and would require a fundamental rewrite of celestial mechanics, suggesting the entire field has been on the wrong track for over 300 years, since the days of Newton and Laplace. So, we're left with two very, very different stories about our solar system. You've got one of random, violent accidents, and then you have this other one of a hidden, almost clockwork-like precision. Mathis's theory, with its simple rules and these startlingly accurate predictions, it really forces us to ask, what if the lazy answer is the one that's been staring us in the face all along?